Imagine an F1 pit stop. A single millimeter of misalignment on a wheel nut, the car crashes out, you lose the race entirely. Well, Cambridge IGCSE Physics 0625 is exactly the same. Mixing up your units in an energy or power calculation is literally that misaligned wheel nut. Look, it doesn't matter how fast your brain is moving or how well you know the theory, it costs you the grade boundary instantly.
So ask yourself, why did this perfectly memorized area formula just score absolutely 0 marks from the examiner? The student correctly identified that area equals length times width. They did the revision. You have the physics knowledge, but the execution just blew a tire, and the exam clock is relentlessly ticking down. You simply cannot afford to bleed marks on something you actually know.
Okay, let's dive into this. On one side, we have a fatal yet incredibly common flaw. The student multiplies 20 centimeters by 10 millimeters, getting 200. Now, the math checks out perfectly on a basic calculator, right? But in a physics exam, it's a total disaster. On the other side, we see the top band approach. Area equals 20 centimeters times 1 centimeter equals 20 square centimeters. The underlying formula is completely identical, but the outcome is wildly different.
The golden rule here is absolute. When calculating length by width, one measurement absolutely must be converted to match the other before your finger even hovers over the calculator. Actually, scratch that. Before you even pick the calculator up. You cannot multiply centimeters and millimeters and expect a valid physical area. You have to convert that 10 millimeters into 1 centimeter first, ensuring perfect, flawless consistency. To prevent this kind of unforced error, you need a highly specific framework that separates ordinary, panic-driven revision from high-mark exam strategy. Here it is. Step 1. Grasp the core concept. Step 2. Extract your evidence and data, performing an immediate mandatory unit match check. Step 3. Apply your scientific reasoning. Step 4. Frame it using exact examiner wording. Let's break down this framework and see exactly how it builds your ultimate defense against lost marks.
It all starts at the absolute foundation, the International SI system. Using these core standard units, meters for length, kilograms for mass, and seconds for time, is exactly what allows us to compare variables and scale calculations easily. Think of it as the universal language of physics. If you aren't actively checking that your variables are in these base SI units before you hit equals, you're already driving off the track. But here is where the track gets slippery. Enter the derived unit. A derived unit is based on a calculation, like meters per second for speed. The slash symbol literally indicates division, the number of meters traveled in each individual second. The dangerous trap here? Correctly calculating a value using standard meters and seconds, but then carelessly writing your final answer as kilometers per hour. It's a tiny slip, but it ruins the whole calculation. And this brilliantly illustrates how mastering specific derived units is absolutely non-negotiable for 0625 physics. Force is in newtons, energy is in joules, power is in watts. If you're calculating work done or energy transfers, you must know that your foundational inputs lead directly to joules and watts. Misalign your input units, and the entire derived unit collapses like a house of cards. Now, we are approaching a critical sector of this explainer, the hidden conversion trap that routinely costs students their target grade boundary. In a moment, I'll show you the exact examiner clue regarding squared and cubed units that changes your final answer completely. But first, you need the framework that makes that clue absolutely obvious to top-tier students. Here is the resolution to that trap. Linear conversions are simple, right? To get from centimeters to meters, you just divide by 100. But area and volume? Wildly different. Because area is squared, converting square centimeters to square meters means dividing by 100 squared. That's 10,000. And for volume, which is cubed, there's no way around it. You have to divide by a massive 1 million.
Okay, let's put you in the driver's seat for a second. I want you to actively pause this explainer right now and predict. How do you mathematically convert 5,000 square centimeters into square meters? Think carefully about the rule we literally just uncovered before I reveal the examiner's mark scheme. Go on, pause it.
So the crucial point is, if you simply divided 500 by 100, you fell into the most common trap on the paper, ending up with 50 square meters. The correct process for an area conversion is dividing by 10,000, giving you 0.5 square meters. That right there is how you secure the method marks and completely protect your overall score. And you know, this isn't just about conversions.
Direct examiner feedback reveals a massive pattern of operational failures across the board. Missing units entirely, rounding numbers way too early in multi-step calculations, offering vague explanations, plugging in the wrong variables, or drawing conclusions not supported by the data. Losing marks here is exactly like an F1 car failing to secure a lug nut. It's a basic operational failure that ruins an otherwise perfect race strategy.
Now, what's really interesting about this slide is that the source material makes it absolutely clear. In a calculation, the units you use must match, or be consistent with one another. Guys, it's not a suggestion, it is the absolute law of Cambridge physics examinations. The whole shebang hinges on this consistency.
Before you ever move to the next question, you must run through these final exam safety checkpoints. Think of it as a pre-flight check. 1. Confirm unit consistency across all variables. 2. Check your significant figures. 3. Assess physical reasonableness. Like, does this number actually make sense in the real world, or did you just calculate a toy car moving at the speed of light? And 4. Ensure you have precisely fulfilled the specific command word used in the prompt. This is your absolute safety net.
But this brings up a massive, potentially grade-defining question. What if your calculations in units are absolutely perfect, but your written scientific reasoning completely fails the examiner's standard for a top band mark? Unit consistency gets you on the board, sure, but how do you actually dominate the written evaluation when the pressure's on? That leap from having perfect units to delivering flawless scientific reasoning is the final piece of the puzzle, and we have an entirely separate framework for the exact traps examiners set for written answers. Your next lap requires Video B. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. See you there.